Our first example has us using the commutative property. Remember, commutative property is the one that says changing the order doesn't matter. So 2 plus 29 is the same thing as 29 plus 2, because both of them equal 31. And m times 10 is the same thing as 10 times m, which usually, when you see it written in algebra, would be written with the coefficient coming first, the variable second, and no operation between them. If there's nothing between the letter and the number, it's implied that you're going to multiply. To use the associative property, we're going to try an example here that has some numbers in it. You'll see that multiplying 4 times 3 elevenths just would give us 12 elevenths, which doesn't really do much to make this simpler. But if we rewrite the problem with the grouping changed, grouping the 3 elevenths and the 11 together instead of the 4, we can add a 1 under the 11 to turn it into a fraction, and then cancel the 11s. So we just end up with the problem 4 times 3, which is an easier problem to do than 4 times 3 elevenths and then multiplying by 11. The associative property can also help us simplify algebraic expressions, meaning expressions that have letters in them. We can't add the y and the 12, but we can add the 12 and the 3. So if we move these parentheses to make this expression y plus 12 plus 3, we're able to simplify it further into y plus 15. That will also help us with this multiplication problem over here. By changing the grouping to multiplying the 2 sevenths times 7 halves first, both the 7s and the 2s are going to cancel out, leaving with us just one big old 1. So the answer to this problem would be a negative 5/8. The distributive property, remember that's the one where we distribute what's on the outside of the parentheses to everything on the inside of the parentheses. So you'll notice that when we use the distributive property, we end up with 2 times 4 minus 2 times 3, which would give us 8 minus 6, which is 2. That's the same answer that we get if we follow order of operations. 4 minus 3 gives us 1, and when we multiply 2 times 1, we also get 2. Now in this one, it looks like there's not anything to distribute, but there's actually an invisible 1 right in between that negative sign and the parentheses. So we're distributing a negative sign or multiplying by a negative 1, whichever one makes more sense to you. You can either think of it as just distributing the sign, or you can think of it as distributing a multiplied negative 1. In any case, it's going to leave us with a negative 5 and a positive 2. And negative 5 plus 2 leaves us with negative 3. We would get the same thing if we followed order of operations. 5 minus 2 is 3, and then applying the negative sign later, we also get negative 3. One more set of examples. Applying the distributive property over an algebraic expression, we're going to get negative x minus 5 plus 7, and then when we combine these two terms, the negative 5 and the positive 7, we'll get negative x plus 2. In this problem, we're going to distribute the negative 3 both places, giving us negative 3 times 4 minus a negative 3 times 9y. Negative 3 times 4 is negative 12, and a negative 3 times 9y is a negative 27y. That subtraction that's outside the parentheses we haven't used yet, so we're going to keep that there for this first step. Then you'll notice that we have minus a negative. So thinking about what you know for adding and subtracting integers, that minus a negative is going to make our final answer be 12 plus 27y. And that is as simple as we can get it until we find out what the y is.